A very good day to you, learners. Very good day to you, geography learners. Welcome to our geography discussion on paper 1 for grade 10. Right, so we are going to focus on our discussion in preparation for the geography final examinations for grade 10, paper 1. We are going to focus on the discussion on our paper 1 questions, and we are going to analyze how best we can answer those questions. It also is not only a matter of answering questions, but it's a matter of also trying to highlight on how best we can respond to a given type of questions, which are typical examination questions for that matter. Right, so what is going to happen is we're going to go through our assembled paper that we're going to be discussing on, and we are going to just highlight on the questions and discuss and give the possible responses. Right, and as usual, I must understand that your geography paper, which is a full paper, by the end of the year, you are supposed to write a full paper out of 150 marks. And that paper is to be covered in 3 hours. And the sections that are supposed to be covered, remember, for paper 1, you are supposed to refer back to topics for term 1 and topics for term 1 content is basically the atmosphere, and that is question number 1 in section A, and that question is going to be out of 60 marks. And then your question number 2 is going to be question number 2 is going to be geomorphology. Ask number 3 to give a total of 150 questions and do the discussion, and also try to find the possible answers to the questions. Right, so what is going to happen here is the first question is refer to the sketch below showing the water cycle. Choose from the terms given here. Is 1 evaporation, then we also have condensation, and we have precipitation. These are the 3 terms that we are going to use to answer the questions. It's either evaporation, or it's condensation, or it's precipitation. So you must understand these aspects here before you answer the question. You must understand them, what they imply in geography. Right, when you're looking at evaporation, we are saying liquid water here is heated. There is addition of heat, is heated, and then it becomes water vapor, which is a gas. So this is the process of evaporation. We are saying liquid water is heated, there is addition of heat to liquid water, and it turns into water vapor or into a gas. Then condensation, we are saying it's a gas, which is our water vapor. Our water vapor in this instance. What happens to the water vapor? When the heat is reduced, is cooled. When it's cooled, it becomes water droplets. The water droplets are the ones that we see as clouds. If the gas is cooled, the water vapor is cooled in upper atmosphere, the water cools down and changes from being a gas, and it becomes water droplets that results in us seeing clouds in the atmosphere. Then precipitation. When we're talking of precipitation, we are looking at any form of moisture from the atmosphere. Any form of moisture that reaches the ground surface from the atmosphere. There are different types of precipitation, mainly rain. It can be snow. It can be all those forms of moisture that come, can be hail. Those are forms of precipitation. Right. So we're going to use those three, refer to precipitation, refer to condensation, to evaporation, to answer the questions. Right. Let's go to our questions. The first question is saying dash occurs when water changes from liquid to gas. We have talked about that. From liquid to gas, that is evaporation. Right, then the second question, dash happens when water changes from gas to liquid. From a gas to a liquid, what process is responsible for that change? It's condensation, like what we have mentioned. Then dash occurs when water falls from clouds. When water falls from clouds, what happens there? That is precipitation. Dash is an example of, snow is an example of what? Snow is precipitation, as we have highlighted. Then the heating of water surface will result into, the heating of water surfaces, it will result into evaporation. Remember, we said if heat is added to water bodies, to liquid water, it turns into a gas or water vapor. So if the water bodies are heated, the dams, the rivers, the lakes, the seas, if they are heated, then the water tends to become a gas, which is in the form of water vapor, and it rises into the upper atmosphere where it condenses to form clouds that will result in the formation of precipitation. Right. Mist, number 116. Mist is an example of condensation. Right. What I must clarify here is what we see as clouds in upper atmosphere is what we see as mist or fog close to the ground surface. If condensation happens close to the ground surface, it results in misty conditions or in foggy conditions, depending on the amount of water vapor and the availability of hygroscopic nuclei of condensation in that particular atmosphere. So if, for example, if condensation happens close to the ground surface because of excessive loss of heat because of long wave radiation, for example, in cloudless winter nights, we tend to find that if there is moist air which is exposed close to the ground surface, condensation just happens is excessively cooled by terrestrial or long wave radiation, and as a result, we tend to find that the water vapor in the moisture in the air is going to condense just close to the ground surface, resulting in the formation of misty conditions. So it's condensation. Right. Then number 117, clouds form when dash occurs. It's again condensation. When condensation occurs, we tend to find clouds forming. Right. Then let's go on to the next part. The next part is saying it's 1.2. Choose the correct words from those given in brackets. Write only the words next to the question number 1.21 to 1.28 in the answer book. For example, 1.2. Let's check on the first question. The first question is saying insolation or reflection is the amount of incoming sunlight that is bounced off clouds and Earth's surface back into space. The one that is sent back is reflection. Insolation is incoming solar radiation. The one that has been received by the Earth's surface, that is insolation, the amount of heat that we receive from the sun. But the one that is reflected back, for example, because of shine surfaces or shiny clouds, they tend to send back the heat into the atmosphere. So that is reflection. Then number 122 is heat insolation or absorption, which is the amount of incoming sunlight that strikes the surface. We have talked about that. That is insolation. Heat transfer of heat in the form of waves is known as, in the form of waves, transfer of heat in the form of waves, that is radiation. If heat is transferred in the form of waves, radiated. That is radiation. Right, moving on to the next question. Conduction or convection is the transfer of heat between substances that are in direct contact with each other. When you are looking at direct contact, that is conduction. Conduction. The molecules of a substance, they pass heat from one another because they are in close contact. They transmit the heat from one to another because of contact. That is conduction. Then number 125, the transfer of heat by circulation of warm and cold air is called. The transfer of heat, that is convection. Convection currents. I think you understand convectional rainfall. When the ground surface is above, the ground surface is heat up and it gets cooled, and when it gets cooled in upper atmosphere, it becomes denser and then it sinks down because of its density. Then it brings in colder conditions on the other side. That is called our question is saying latitude or albedo is the measure of how much a surface reflects heat. How much a surface reflects. Reflection of heat is called albedo. In other words, we are saying albedo, it refers to reflectivity. Shine surfaces have got high albedo, which means they are able to reflect heat. Glass surfaces, they have high albedo, which means they don't absorb heat and they tend to reflect. White surfaces, white painted surfaces, they have got high albedo. So that is reflectivity, that is albedo. Right, then we move on to number 127. 127 is saying ocean currents or river flow are large-scale circulations of ocean water. Ocean water is ocean currents. Remember, we have the two main oceans which are responsible on the east and on the west. Right. Let's move on to the next question. The sun's energy is called, is it solar radiation or terrestrial radiation? That is solar radiation. Solar radiation, that is the amount of the energy that comes from the sun. Terrestrial is also, in other words, called, is the other term for terrestrial is long wave radiation. This is the heat that comes during the day. At night, we have some form of loss of heat from the ground surfaces, which tends to regulate global temperatures. If it was not the sake that we have long wave radiation, otherwise the Earth's surface would have overheated because of continuous receival without shedding off some of the heat that has been received. So we have long wave radiation, which is terrestrial, which is the loss of heat from the ground surface, and then this is short wave radiation. It comes in the form of shortwave radiation, in the form of the ultraviolet rays, the visible rays, and this one is invisible. Right. Moving on to the next question, we take it to question number 1.3. Question number 3, we move on to question number 3. 1.3. 1.3 is referred to the graph below, showing how temperature changes with the height between different layers of the atmosphere. And then our first question is a question on definition. The question is saying define the concept atmosphere. Right, what you must understand, you must be familiar with the layers of the atmosphere. Remember, our atmosphere is made up of some distinct layers. Starting from the ground surface, we have our troposphere, which is the lower bottom part of the atmosphere, where we are situated. And from that layer, as we go up vertically up with altitude, we reach the upper limit or the upper boundary of that particular layer, the first layer. The upper boundary of the troposphere is what we call the tropopause that we find here. So it's troposphere, the upper limit is a pause, which is a tropopause. Then the next layer is the stratosphere. And after the stratosphere, we have the stratopause. Then it means the third layer comes as the mesosphere. And again, after the mesosphere, there's a mesopause. And then we go into the thermosphere, which is the uppermost. And also what you need to check here is you need to understand the changes in temperature with increase with altitude. Like here in the troposphere, you are seeing that the temperature profile is negative. As height increases, the temperature decreases. And as you get into the stratosphere, as altitude increases, we see that the height increases. There is a positive profile. And as you go to the mesosphere, again, the profile becomes negative. An increase in altitude results in a decrease in temperature. And lastly, it's positive in the last layer. So our first question is saying, define the concept atmosphere. So in simple terms, we can say the atmosphere is the air that surrounds the earth. Thus, in simple understanding of the atmosphere, we're looking at the air that surrounds the earth. That's our atmosphere. Choose the correct word from those given in brackets and that describe the temperature pattern. In the troposphere, we are looking at the troposphere here. Is it getting colder or hotter with an increase in height? Definitely it's getting colder in height. In other words, the temperature, it decreases with altitude. Thus, the impression of the profile. Describe the temperature pattern in the thermosphere. In the thermosphere, we are seeing the last layer here. How is the temperature like? The thermosphere, the temperature increases. In the thermosphere, we are seeing that the temperature increases. It's increasing, the temperature increases. Then why the temperature increases in the stratosphere? The important part that you must note in the stratosphere is where we have our ozone layer here. So what makes the temperatures increase in this layer is the reaction. The reaction between sunlight and the ozone. And the ozone in upper stratosphere generates heat. So that reaction between the sunlight and the ozone in the upper stratosphere is the one responsible for generating heat. So that heat will result in an increase in temperature. So the reaction between sunlight and the ozone in the upper stratosphere relates to the generation of heat in that layer. Right. So name one. Then the next question is saying, we're answering number 1.3. Then 1.5, it says, in which layer of the atmosphere will we find ozone layer? I think that is clear. We find it in the stratosphere. Stratosphere. That is where we find our ozone layer. Right. Taking it on to the next question, is saying, name one human activity responsible for ozone depletion. There are so many human activities that contribute towards ozone depletion. Some of the notable human activities will relate to activities that involve the use of CFCs. Right. If you are using CFCs, for example, in aerosol sprays, they contribute towards the damage of the ozone layer. And also the use of CFCs as in coolants and refrigerants, they are also responsible, and also in air conditioning. They all contribute towards the damage of the ozone layer. So we are looking at activities that involve the generation of chlorofluorocarbons. For example, aerosol sprays for coolants and refrigerants, and also for air conditioning. All those ones are responsible for the damage of the ozone layer. And also we can look at unregulated rocket launches. They are also responsible. Then we can also look at other activities like nitrogenous combustion, the burning of substances containing nitrogen. They are also responsible for the damage of the ozone layer. Right, explain the importance of the ozone layer. The ozone layer ultimately protects life from the harmful UV rays from the sun. So the ultraviolet rays from the sun, which are equally harmful, they are shielded from getting to cause harm on the Earth's surface by the ozone layer. That's the importance of the ozone layer. It helps us, it protects us from harmful ultraviolet rays coming from the sun. Right, then look at the last question. Suggest methods that can be implemented to reduce ozone depletion. What methods can we put in place to reduce the depletion of ozone? We understand that ozone is very important for the reasons highlighted. And what must we do to reduce? We must use ozone-friendly products, desist from using products that cause harm, and use products which are ozone-friendly. And also we must replace CFCs, or chlorofluorocarbons releasing substance must be replaced. Then we can also use the planting of trees. Planting more trees can also help. Then we can also look at other activities like use of public transport. Instead of using own transport, private transport, we opt to use public transport to reduce the amount of emissions. And also we can look at educational awareness programs. People sometimes they cause harm to the environment because they do not know the consequences. So we need to educate them and to make them aware of the side effects of them harming the ozone. And then we can also look at other things like introduction of carbon tax, other activities like also introduction of electric vehicles. It's also another viable way. We can also look at other things like saving electricity. Right, we cannot exhaust all. Those are some of the ideas that you can use to answer that particular question. Taking it to the next question, it's question number 1.4. It says, due to climate change, the country's rainfall patterns have become more erratic, leading to flash floods and water scarcity in some areas. Thus, the text is a text on global warming. Define the term global warming. That is the first question. When we're defining global warming, we're referring to an increase in the temperatures, increasing temperature near the Earth's surface. We are saying the Earth's surface temperatures are increasing. That is the issue of global warming. The globe is warming up. The temperatures are rising. That is the effect. That is the idea of global warming. Right. Then it says number 142. Name one human factor that contributes to global warming. What are human factors contributing towards global warming? Global warming is facilitated by burning of coal. And talk of coal for electricity generation, for example, when we burn coal for power generation, our thermal power, we are causing harm to the environment by increasing the amount of pollutants in the atmosphere that will trap the heat and cause a rise in the global temperatures. Then you can also look at other things like deforestation. If you're cutting down trees, it is going to contribute towards the global warming. And also, if we look at other fuels, burning of other fuels, the oil-based fuels for transportation, they also contribute towards global warming. The burning of oil-based fuels like petrol, diesel, all those fuels. According to the article, which weather conditions have become more common in South Africa because of global warming? Right. We want to identify the weather conditions which are more common. We are seeing that it says the drastic swing between extreme drought and also unprecedented flooding. Those are typical examples that we find of consequences of weather conditions that are becoming common in South Africa. We're having issues of extreme drought and also having issues of unprecedented floods. Right. Describe the two consequences of global warming mentioned in the extract. The consequences that are mentioned here, it is saying that water stress is expected to significantly affect poor, de-enfranchised communities as well as the problem of water stress. Then the intensity of drought and rainfall is sharply increased over the past years, which is relating us to aspects of crop failure, infrastructure damage, and humanitarian crisis. So it's 1, it's 2, it's 3, and then it's 4. You can discuss on those. Like you just have to give a brief description of those problems, like water stress, how does it impact, and also the problem of crop failure and also infrastructure damage. Right, in a paragraph of approximately 8 lines, I recommend sustainable solutions the government can implement to stop or slow down global warming and climate change. What can the government do to reduce global warming and climate change? We can introduce the reduction of greenhouse gas emissions. Find ways of reducing the emissions of greenhouse gases into the atmosphere, or can use alternative fuels or sources of energy. In this instance, renewable energy sources. We move away from fossil fuels and we try to introduce more cleaner sources of energy. Then we can also use public awareness. The government must be conscientized and must be aware of the dangers of causing global warming and the resultant climate change. Then you can also look at other things like saving energy. Look at other things like we drive less. Or can suggest use of public transport. Then also can advise on use of recyclable products that can be recycled. They will assist in the process. Right. So we are looking at some of these strategies as ways of trying to, the government can put in place to limit and also try to control the problem of global warming and climate change. Right, let's go to number 1.5. Refer to the sketches below on types of rainfall and synoptic weather map. Right, there's relief frontal convectional, and also there's our synoptic map. The date is here, 2010, January 30. Right, and we have these weather systems. Kathy, this is a tropical cyclone, and this is a mid-latitude cyclone with a cold front and a warm front, and then this is an anticyclone, and also this is another anticyclone, and this is the interior, the South African subcontinent is here, and we have a weather station on this part here. Right, so the question says, what are the black lines on the synoptic map? These lines here, what are they called? They are called isobars. And what are they for? They are therefore to align places of the same atmospheric pressure on the synoptic map. They join places of the same atmospheric pressure. Is the pressure cell at A high or low pressure cell? Right, if we check where is our A, and A is here, and I've already mentioned that this is an anticyclone. Right, it's out of geographical knowledge. We know that to the west we have an anticyclone over the ocean, and to the east we also have another anticyclone over the ocean. And our anticyclone, we are saying, if we talk of an anticyclone, we are looking at a high pressure cell. But let's use the geographical information on the map to suggest whether it's a high pressure cell or a low pressure cell. We check these ones, the isobar values. It's 1008, 1012, and 16 and 20. So if we see our values are increasing going towards the center of the cell, which is A, so it implies that the pressure is high here at A because the values are increasing going towards the center of the cell, which is at A. So we have answered 152, it's a high pressure, and we have given a reason. The isobar values are increasing towards A, which is the center of the cell. So as they are increasing, it shows that it's a high pressure cell. Right. Describe the wind speed of station model D. Station model D is found here. Our wind speed, we find it by the feathers at the end of our arm. So if we check, though it's not very clear, but our suggestion here is that is half a feather, which means it is clarified and classified as 5 knots. One full feather is 10 knots, but if it's a half, it means it's 5 knots. So we assume that is half because it seems like it's a very small feather at the end. If it was a full feather, it was supposed to be presented a little bit longer than how it appears there. Then identify the front at F. Our F is here. The line with these triangles, this is a cold front. That is how a cold front is portrayed. And these semicircular ones here, they present a warm front. So our front at F is a cold front. Then what type of rainfall is associated with F? Already the front part gives us frontal rainfall. Right, explain the formation of the type of rainfall mentioned in question 151. Frontal rainfall, how does it form? Frontal rainfall forms as a result of cold, dense air undercuts warm, moist air. What will happen? Warm air rises, reaches dew point, cumulonimbus clouds form. Which will result in heavy rainfall. So the frontal part is that there's a boundary between cold air and warm air. But because cold air is more denser, it advances further towards warm air. And because of its density, it takes the bottom part, which means it undercuts, it takes the ground part, leaving the warm air to be uplifted in the upper atmosphere. And as the warm air uplifts, it reaches a dew point where the moisture in the air begins to convert to become water droplets, and that results in the formation of towering cumulonimbus clouds that result in heavy rainfall. Right. Then it says differentiate between convectional and orographic rainfall. What is the distinction between convectional, these types of rainfall, convectional, and then we have orographic. Orographic is also called relief or relief. Right, let me use the illustration to explain this. What is going to happen here with our convectional rainfall? Right, we are saying the sun, it heats up the ground surface and water bodies. All moisture which is on the ground surface here is affected by the heat which is coming from there. Remember, we said when water bodies are heated, there is evaporation. So the water bodies, as they are heated, the water, it turns into a gas, which is water vapor. It starts to rise because it's dense, less dense because of the weight of the heated air molecules. So it rises. So it's the heat from the sun which heats up water bodies. The water in the water bodies, it rises as water vapor, and it reaches condensation level, which is the dew point temperature, and clouds form. These clouds will result in rainfall. That is basically convectional. So it results in convection currents. Right. And relief is formed by a barrier, which can be a mountain. We have warm and moist air here. It's coming from the ocean. This air is blowing inland, is blowing into the land, but however, there is a physical boundary barrier here, which is a mountain. The air cannot filter inside the mountain, but rather is forced to go up. As the air goes up, it reaches dew point temperature, where the moisture here begins to condense and form clouds. And these clouds are going to result in rainfall. And the rainfall, for relief rainfall, is received on what we call the windward side. This side of the mountain is called the windward, where we receive rainfall. And as the mountain goes the other side inland, this is called the leeward side. Leeward side of the mountain, here it will be dry. The air is now dry because the moisture has been finished in forming these clouds and forming rainfall. As it goes down here, it's now dry. There's no more moisture. So that is basically how relief rainfall forms. We have the windward side, that is where we experience rainfall, and we have the leeward side, that will be dry. Right. That takes us to the end of question number 1.5. And that's the end of our climate question out of 16. We move on to geomorphology. Refer to the sketches below, which show different types of folding. We have asymmetrical, isoclinal. All those are 6 types of folds. Right, let's answer the questions. The first question is saying an upfold. When you're looking at an upfold, you are saying this is the upfolded part of the fold, like this one here. The upper folded, we call this an anticline, and this downfolded is called a syncline, and then these are called the limbs of the fold. It's a limb of the fold. So the question is saying an upfold is an anticline. Then it says go a downfold is a syncline. Then it says a pointed or peaked fold. That's a chevron, I think you see here. Then a fold with 2 equal sides. 2 equal sides, it's symmetrical. There's a line of symmetry. Like if you check here, symmetrical, if we divide it by here, this side can effectively fold onto this side. So it's symmetrical, there's a line of symmetry. But if you try to compare with this one, this side is not the same as this one. This one is steep and this one is gentle. So the limbs are not the same, meaning to say it's asymmetrical. There's no line of symmetry there. Then it says the sloping bends on either side of an axial plane. Those are the limbs. Then it says a tilted or bend over fold. A tilted is asymmetrical. Then an overturned fold that flopped over, that is a recumbent. Then a very tight fold in which the limbs are parallel or parallel to one another, that is an isoclinal. So those are the responses for question 2.1. We move on to question 2.2. 2.2 is based on the Earth's internal structure. And on the Earth's internal structure, we need to analyze and look at the different layers that form as the Earth's internal structure. Right, we have the crust, which is the Earth's crust, which comprises of continents and oceans. Then we have the mantle, which is comprised of hot molten rock. Then we have the outer core, and then we have the inner core. Those are the 4 distinct layers of the Earth's internal structure. We are going to use those ones to answer the questions. Right, taking to the first question, number 2.21, it says the very thin, solid, brittle top layer of the Earth, indicated as number 1. That is the crust, without wasting time. 2.23, 2.22. The inner core is labeled by the letter inner core. We just come here and see that number 4 is the inner core. The outer core is labeled by number 3. Then the inner core of the earth is made up of, we are looking at the minerals that form the inner core is made up of solid iron and nickel. Right, then we move on to number 5. The layer of the earth that is mined for minerals. Minerals, we find them in the earth's crust. The layer responsible for the earth's magnetic field labeled as 4, we said label 4 is the inner core. Then the mantle, layer 2 consists of, the layer 2, it consists of magma. Remember the distinction between magma and lava. Magma is inside mantle. Once the hot liquid rock is inside the mantle is magma, and once is outside or on surface, on the earth's surface, is now called the lava. So that's the difference there, but both refer to hot molten rock. But once it is still contained inside the mantle, it's called magma. Once it is exposed and it erupts as a volcano, it becomes referred to as a different term, which is a lava. Right, that takes us to the end of question 2.2. Let's move on 2.3. It talks about plate boundaries and plate tectonics. Right, define the concept plate tectonics. When you're looking at plate tectonics, it's a theory that suggests that the Earth's surface is made up of a number of plates, several plates that are slowly moving. That's the idea of plate tectonics. We are saying the Earth surface is divided into different plates, is broken down into different plates, and those plates are constantly moving. Right. So let's go to the next question. It says, choose the correct words from the given words in brackets. Plates push together. When they are pushing together, they are converging, the convergent boundary. And at a dash boundary, plates slide past each other. It happens at a transform. That is where plates slide past each other. Then plates move apart at a, to move apart is to diverge. That is a divergent boundary. Then number 233, name one landform formed when convergence occurs between two oceanic plates. Convergence occurs between two oceanic plates. When two oceanic plates converge or collide, they result in the formation of what are called the island arcs, or what are also called the volcanic islands. Then says, name one landform formed when convergence occurs between two plates. When we have two plates, in this place we are referring to continental plates. Continental plates, if they converge, they result in the formation of fault mountains. For example, in South Africa, we have the Cape Fault Mountain. That is typical example of the fault mountains that result in the collision of two plates, continental plates for that matter. Distinguish between mid-oceanic ridge and oceanic trenches by referring to the different ways they form. Right, we are looking at the mid-oceanic ridge and then the oceanic trenches. The mid-oceanic ridge, how does it form? We are looking at forms when our plates are moving apart. Oceanic plates move apart. We are saying in the midst of the oceans, there are two plates which are moving apart from each other. What is going to happen if plates move apart from each other? It means if they are pulled apart, magma rises. Because now there is a space, plates are moving away from each other, the magma rises and solidifies. And as the magma solidifies, it creating new landforms. And these landforms, usually we call them the mid oceanic ridges. A mid-oceanic ridge, we are saying it's a range of mountains which are inside the oceans. A range of mountains that we find inside the oceans. And those range of mountains, they are deemed to be growing. They deemed to increase in height because as plates move away from each other, more magma is released and the height of the landform increases also. So the mid-oceanic ridge is formed by that particular formation of divergence of two oceanic plates apart from each other. Then the oceanic trenches, how the trenches form, they form as a result of an oceanic plate which is denser in this instance. When I'm comparing the two, an oceanic plate is more denser compared to a continental plate. And a continental plate, they converge. The two converge, they move towards each other. And what is going to happen? The denser here, which is the oceanic, it slides under the continental. So by doing so, it means it is going to create very deep parts of the sea, which are the trenches. So it slides beneath the continental crust, resulting in some areas of deep waters within the oceans and the seas because of the sliding beneath, which is done by the oceanic plate. Right. Then we move on to the last question. Explain what causes tectonic plates to move. Tectonic plates to move, remember we are looking at the plates are floating on hot liquid rock. We are saying it's a solid which is suspending on top of a liquid. Then there's a tendency of it to move in a direction. And also, we need to relate to convectional currents within the mantle. Convectional currents within the mantle, they drive those plates. Either they are driven towards one another or they are driven away from each other. That gives us rise to transform faults if they are sliding past each other. That gives us rise to convergent plate boundaries if they are moving towards each other. And that gives us rise to divergent plate boundaries if they are moving away from each other, depending on the direction of movement of the convectional currents within the mantle. Right, we move on to the next question on earthquakes. We are not going to go through the text, but we are going to answer the question. What instrument is used to measure the magnitude of an earthquake? We are referring to the strength of the earthquake here. What do we use to measure the strength of the earthquake? Is measured using a seismometer, or can use what you call a seismograph. Right. The meter is the one that is used to detect the strength of the shock waves and is presented on a graph, which is the seismograph. Right. What is the epicenter of an earthquake? The epicenter is a point on the surface. In this instance, we're referring to the Earth's surface that is directly above the focus of the earthquake. The earthquake has got a focus, which is the starting point where the shock waves start from, the focal point where the shock waves start from. So the epicenter, we're looking at a point which is directly on top of that particular point where the earthquake starts. So this one is on the Earth's surface. The focus will be within the Earth's crust where the Earth shock waves originate. But the focus will be on top of the Earth's surface. That is where it is located, but is directly on top of the focus. Where was the epicenter of this earthquake? According to this, we are seeing here, it was in Klerksdorp, somewhere there. So we are saying our epicenter for that reference was Klerksdorp. Quote from the extract which described the earthquake as only moderate. Moderate, we are saying the earthquake was not very destructive, was not very powerful. It was average in terms of its strength. It says It can cause damage to buildings with poor construction, and everybody will feel its tremors. That's the suggestion, that the earthquake was moderate. If it was very strong, it was going to cause widespread destruction, despite the buildings being poorly constructed. Right. That takes us to the next question. Explain why mining activity can be the possible cause of this earthquake. How does mining contribute towards earthquake? Right. We are looking at mining here, resulting in underground excavation. We are extracting from underground. Underground excavations, how do they impact? The underground excavations in this instance, they can lead to stressors. That cause earthquakes. So we have the stressors, we're having areas of weaknesses because of extraction. We have extracted part of the interior of the Earth's internal structure, which is supposed to be supporting the ground surface. Therefore, it causes a stress, an area of weakness because of the extraction which is happening underground. And then that can facilitate the shock waves to develop because there is some weakness within the Earth's crust. It's no longer solid, but now is having some areas of weakness is created by the extraction which is happening as we extract the mineral ore. Right. In a paragraph of approximately 8 lines, explain the effects of earthquakes and suggest ways on how the impact of earthquakes can be reduced. We want the effects first and how we can reduce the impact. So the effects are just simple. Earthquakes can cause injuries, can even cause deaths, can also cause infrastructure damage, can also result in aspects like fires. It can cause fires where there is a breakage in, for example, gas supply pipes. It can result in fires. And also earthquakes in some coastal areas, it can result in tsunamis or flooding of the coastal areas. Those are some of the effects of earthquakes. And then, how can we reduce the impact? We look at aspects like when we are trying to reduce the impact of earthquakes, we can try to introduce early warning signs, early warnings to alert people so that they will be prepared before the earthquake strikes. And also we can look at aspects like prediction of earthquakes. Then we can also look at use of strong building material that resists shock waves, that can resist minor shock waves. We can also look at aspects like educating people. People need to be educated on how earthquakes must be prepared for and how people must take precautionary measures against. Then you can also prepare it by having enough stocks, either of clean water and food to help people. We need to put in place emergency services to assist those ones who might be trapped and who might have been affected by the harmful effects of the shock waves. So basically, that's the idea that we must address when we want to deal with earthquakes. We move on to the next question. It's on a volcano. That's the illustration of a volcano. So the first question is saying, what is a volcano? A volcano basically is an opening in the earth surface from which magma erupts or comes out. That's a volcano. An opening within the Earth's crust in which allows for the magma to erupt. Then identify the type of volcano. What kind of volcano is this? We are seeing that we have alternate layers. There is ash, there is lava, there is ash, like if you are seeing this by labels here. So if we are having a layers of ash and lava, that forms what we call a composite volcano. And why? Because of alternate layers. It has alternate layers. It's one reason. Of ash and lava for one reason. And also it has, if you check on it,